Good afternoon, everybody. Welcome. It's nice to see so many people here. I am going to talk a little bit about Qt for device creation and boot to Qt, etc. But first of all, let me introduce myself. My name is Nils Christian Roscher-Nielsen. It's a long and unpronounceable Norwegian name. Sorry about that, but you can call me Nils. That's more than enough. I have been working with Qt for the past 8-9 years, and now almost 10 years, I guess, actually. And I've been an employee of Trolltech and Nokia and Digia and the Qt company, working with Qt professionally. And now I am working as a product manager. Tuka, who had the last talk, is one of my closest colleagues. We are working together on trying to define and make sure that Qt is the right thing for all of you guys in the future. Today's session, I am going to do a little bit about device creation, about embedded development, show some of the I'm going to start with some of the challenges for device creators, and then hopefully we can see that there are some solutions also available with the Qt framework. I will be doing a little bit of showing some of our tools and showing how you can use them, and hopefully I will also show Qt running on an embedded device. I hope you can see this device. It's turned off for now, so there's nothing interesting to see yet. It's going to be a little bit small, but we'll have to live with that. Okay, let me just get right to it. So, being an embedded developer is not always very easy, and there's a number of challenges in this industry. And it begins, I think, very much on the embedded space with the simplest of things. You have to find a proper software development kit. Your SDK is extremely important when you're going to do software development. So the SDK, or the software development kit, is a combination of your operating system, your build system, system libraries, middleware libraries, Qt, etc. And that's not always easy. And then you have to interface with the hardware, with the extensions and the things like cameras and GPUs and other features of your embedded device. You need to utilize and make something useful out of all of those fancy extensions that you have available there. And then a very important thing is finding good middleware like Qt to accelerate your actual software development cycle. Previously in embedded development, people have been spending a lot of time on doing very low-level coding, and that's not feasible anymore in a time and a world of rapid development and very high expectations to fast deliverables. And then tooling that enables that rapid development, that iterative development cycle that is becoming more and more common. Okay, so let's just start to look at what are the basics of any embedded software development project. So you need to have a development kit, an SDK, and that typically consists of your system images. That's the actual software that runs on the hardware. It's your operating system and the native libraries running on that device. And you need a tool chain to be able to create something. You need to have compilers and tools that will create native applications that can further run on your device. If you only have the base operating system provided with the hardware vendor, that's not very interesting to sell as a product on its own. And you need to have a sysroot. That's all of your header files, your SO files that you link against, and represent the version of the library in the device you actually have. So that's your development machine representation of the actual device that you're targeting. So all of these things you need to get your hands on. We are focusing mainly on Linux in the Qt company for device creation. Even in Linux, embedded Linux might sound like just one thing, but embedded Linux is a myriad of different things. Embedded Linux is a vast collection of different types, of different kernel versions, of different libraries, of different tool chains. So it's hard to get your own software running correctly and efficiently on any given embedded Linux version. So there's a number of different tools that can help you in getting there. So you have something like the Yocto project, which was briefly mentioned earlier. And Yocto is an extremely interesting and very powerful project. Yocto is defining a number of layers and recipes so that you can easily create a layer-based Linux distribution, basically. You have the base layer, you can have middleware layers, you can have different layers for proprietary drivers that access either the GPU or maybe other, like the radio firmware, etc. So Yocto makes it very simple to build a modular distribution. Similar to Yocto, you have something called Buildroot, which is another system that packages or that creates recipes so that you can build different Linux distributions. Now the difference between the two is that Buildroot forces you or gives you the opportunity to build everything from source. So that's a source code based project, much more than Yocto. And the benefit of Yocto not only having source code is that there's a lot of proprietary drivers where the source code is not available. That's available through Yocto. So whenever your hardware vendor has a specific GPU with a proprietary driver, that can still be available through Yocto, even though they don't want to open source it. Another example is Ubuntu, for example, or Debian. A lot of hardware vendors, they provide a ready-made Ubuntu version with their board, or another version of Linux, where they create an operating system, they create a full framework, and they make a lot of modifications, and you might not have access to all of those modifications, and you might not be able to use them very efficiently. So that can be easy to get started with, but can also be difficult to modify further. So there are pros and cons to all of these approaches. Anyway, this final combination of everything you need is very often referred to as a BSP, and is a board support package, and is something that a lot of hardware vendors provide with their devices. That can be a Linux BSP that contains a specific version of the kernel with patches so that it works on that specific board. Graphic drivers, they are very often proprietary, and as I said, radio hardware, NFC, Bluetooth, GSM, Wi-Fi. This is also very often typically proprietary hardware, and it comes with proprietary drivers that you need to have access to in the BSP. So Freescale, for example, can be providing these things, Toradex, depending on which provider you have of your hardware. And this is something that's important to think about before you select hardware as well. What kind of software will your hardware vendor give you access to? And what ecosystem is there around that hardware vendor to work on, to update, maintain, optimize that board support package or that software, those drivers that you need access to. If you don't have actively maintained board support packages, or if you don't have board support packages that provides you with the features you want access to, it doesn't matter how good your software developers are, it doesn't matter how powerful your hardware is, but the drivers aren't going to be available for you. And that can be a challenge in many cases. Now there's a number of other operating systems, except for embedded Linux, and we are working with many of them. One example is the Android open source project. So Android is a standardized operating system, which makes it very easy to work with. a lot of hardware vendors provide Android-based board support packages because it's a much more standardized starting point, so it's easy to work with, and there's a lot of software available, so it can be easy to start with that. An example of that is in the gym, in the hotel, they have these running machines, these treadmills, and I recognize the software on that. That's actually custom software on an Android-based, very cheap device. So that's easy to do if you want to have a small embedded device that doesn't cost too much. And what you want to be looking for there is there's something called the Android Open Source Project, which is a basis. And then most hardware vendors will provide you either they will just give you their own SDK and NDK, which is from Google or directly from them. But you really want to have access to their source code and their changes and patches to the AOSP, the Android Open Source Project, so that you can build your own SDK and control the tools and the workflow you're working with there. But there are other things than Linux and the Linux world. Windows is a huge and widely used embedded operating system. We are supporting that, we are working with that. And there's typically a little bit different workflow on Windows-based or Microsoft-based systems where you get pre-built images from the hardware vendor. You have less control yourself, so there it's even more important to be in early conversation with the hardware vendors on what you're going to get. Microsoft provides and controls the SDK and the tooling, so you typically have much less control of which choices you have. How can you create the software? It's much more controlled by one company. We are also working with QNX and VxWorks and other real-time operating systems. And here, it's also a much more closed system. Even though there are open source versions of QNX available, this is a much more closed ecosystem where you need to be in contact with these parts, these vendors very early. And I would recommend ourselves as well, because we know where we work well and where we don't work so well with, for example, VxWorks and QNX. So the next point, when you have your BSP, when you have gotten everything you have from the hardware vendor, you need to interface with the actual devices available to you. And here, Qt is a great way of bridging that gap between software or application level software and the hardware you have. So you need to find good middleware, and Qt is an example of that, to use these things. You have a number of platform native ways to interface with the devices, and what we do is that Qt provides an interface with all of these native features. We have most of that readily available. Some of that you can talk to us about. And some things, as Tuka also mentioned earlier, since Qt is a C++ based framework, wherever we don't have a pre-made integration, you can very easily do that yourself in C++ and extend the level of support that we have for yourself. But for most of the things that you need to do on these devices, we take the hassle away from that. So one example of that is audio management. You don't have to know anything about ALSA to do audio management on an embedded Linux device. We have interfaced with that. We have very standardized and simple APIs that are cross-platform that you can use on any device, if it's desktop or embedded, if it's Linux or Windows. You can interface with sound in the same way. But for embedded Linux, we are integrating with ALSA, so we take the pain away from figuring out how you need to do that. And similarly, we have interfaces for cameras and sensors, for GPUs, for radios, as we talked about. And Tuka also mentioned these buses, serial buses, etc. And yeah, Bluetooth is a very good example there. So there's different libraries available for Microsoft, for Linux. On Linux, for example, it's Blues over dbus. Windows uses a completely different API. but we expose the same API for Bluetooth development. And then the next step is doing something with this. When you have access to all of these features, you need to develop something for it. And there, you really need to have a fast development workflow. So Qt provides everything you need to really fast and cheaply and efficiently write user interface applications. And that's what most people think about when they think about Qt. A lot of people, they come to me and they ask, oh, Qt, is that the user interface framework or the GUI framework? And yes, that's true, that's what we do, but we also do a lot more. So typically people think of things like buttons and menus and labels, radio buttons, all of these standard features of a user interface. And we really makes it simple to convert the design or the design vision of your company into a user interface, but there's also a lot of other things you need to think about that are specific to embedded development. Internationalization is becoming more and more important. You're selling products, you're selling, or you're having an international user base. So you need to be able to provide translations of the applications. You need to provide left to right text, right to left text, different languages, different locales. Here, obviously, I think Latin 1 is not enough of a character set in a world where you want to target a global market. And different input methods, like we briefly touched upon earlier, virtual keyboard, for example, or other ways of interacting with devices is very important. So there we have a lot of features already. To kind of sum that up a little bit, this is probably not so easy to read from the back. The projector is not so sharp. I will, or we will distribute the slides afterwards. So hopefully you get a more comprehensive view of this. But this is an overview of all of the features that we provide to do these and solve these tasks with Qt. So there's a lot of features available in Qt. On the GUI side, as you can see on top, but also on the non-UI related side, as you can see on the bottom. Everything that has to do with controlling your application, the process model, the threads, containers, all of these parts are also part of the UI, or part of the Qt offering. Okay, and then when it comes to tooling, having a nice and efficiently working development environment is very important. So for that reason, we have been developing Qt Creator, which is a very powerful integrated development environment. And deployment to the device, as we will see, remote debugging and profiling, and simulation of your embedded hardware can also be very important to have an efficient workflow. So in a minute, we will look a little bit more into Qt Creator, and hopefully you'll get to experience that. How many of you have used Qt Creator so far? Okay, a couple of people have already used Qt Creator. Yeah. For embedded development, it's also very important to scale to the hardware you have. Depending on what kind of hardware you have and depending on what kind of requirements the end product needs to have, there are very different solutions you can use. And in Qt, we really try to focus on enabling any of the features you want. So we have different UI solutions available for different problems. Qt widgets is the traditional, more static UI. And HTML5 is there so that we can support any web hybrid type application. You can mix and match HTML5 and native UI. Then that means you can access a large ecosystem of HTML5 developers. At the same time, you can also leverage much more efficient, fast, and highly performing native UIs. And then Qt Quick is really that language to enable fast and powerful native user interfaces. They are dynamic and they are what we really recommend people to start using today. One of the most important things about Qt Quick is that it allows for developer and designer collaboration. You can easily export user interfaces from design tools and work directly with them in QML, in Qt Quick. It's a declarative language which makes it much more powerful for modern UI paradigms than traditional C++. And it's very easy to work together between the C++, the heavy lifting of the actual application that we want still people to implement in a language like C++ that is much more suited for the task. But then you can do the tiny UI bits and the look and feel in a very convenient language, QML and the Qt Quick module. Now, all of these things are challenges, solutions, and things we have seen over and over again. So, as Tuka briefly mentioned, we decided to create this boot to Qt reference stack to solve many of these problems. So, Qt for device creation, that's our embedded product. And as a part of that product, we have the boot to Qt stack. That's the base Linux stack that we provide for all of you who want to use it, that you can use when you want to create embedded products. Now, that's a lightweight Linux stack. It comes without X11, so it's very lightweight and simple to use. It comes with a ready-made embedded Linux image that you can flash to your device. We support a number of devices, but this is based on Yocto, so it's easy to extend to other devices that we don't support as well. And I'll talk a little bit more about that later. And there's a number of build scripts so that you can further customize the images and the SDK. One thing that is important to mention is that the boot to Qt image, the Linux stack that we are providing, that's a general developer stack. So it contains everything, all the modules of Qt, all the kernel modules from the Linux distribution, etc. And that makes it very simple to do development. It makes it very simple to add new features to your application. But it, of course, comes with a cost, and it takes slightly longer to boot, and it's not as lightweight and small. Now, that doesn't mean it cannot be. It's very simple to make it lightweight. But when you start that application the first time and you think, this is a little bit slow to boot, it's boot slowly, that's just because it's a developer version containing every possible kernel module and Qt library so that you can easily deploy your application. So when you're nearing completion of your project, you should really start looking at removing everything you don't need to get a faster boot time and a smaller application deployable. Okay, so here are some examples of devices. These are both IMX6 devices. One is from Freescale, I think, and the other is a Colibri VF61, the left one from Toradex. I have here with me, if you can see this, another IMX6 based device from Freescale. This is the Sabre board, and this is one of the devices that we support out of the box with Qt for device creation. So I'll try to power this on now. Let's hope everything goes according to plan. Things are probably going to fail since it's live. I hope you can see this. It's very small, so we will show it outside also afterwards, so you can come and ask further questions there. But this is now loading our Linux kernel and booting directly into a Qt application. The application that's being showed here is our standard demo launcher. It is an application that here we can scroll between a number of different applications, and for example, one of them is showing our virtual keyboard so that you can do input handling through that. And there's a number of others. It can show the web engine that we have. It can show some of the 3D effects that we have, etc. So this is the standard thing you start working with when you have boot to Qt. But our demo launcher is not so interesting. You want to develop your own application, and to do that, we have to open up Qt Creator. So let's see if you can see this. So this is Qt Creator, and I can try to so it's a little bit small text, I apologize for that, but let's see. So, do you still hear me in this microphone? What we can try to do is create a new project just to show how we can work with Qt Creator. And there's a number of different types of project we support here. So if we start with making a new application, we can have a Qt Quick controls application that are using the Qt Quick module and the Qt Quick controls that we have ready-made for you that makes it very simple to create applications. And I can call this just a small application. Next, and we can define which is the minimum Qt version that we support. We can say Qt 5.5, that's the latest one. We can enable native styling, and we can use .ui.qml file. So .ui.qml, that's the QML or the Qt Quick file format that allows you to use our visual drag and drop editor to create the user interface. And here we have a number of kits, and we can talk a little bit more about what a kit is. But a kit basically provides you with a combination of the embedded Linux or the Linux, the target device, the Linux version on there, the tool chain that you're using, the host development environment on your machine. All of the things you need to do embedded development is contained in this kit. There is one kit here for desktop, as you can see, and there's an emulator kit. And the emulator allows you to run the embedded software on your development machine. If you don't have enough hardware for the whole team, or if you're traveling, if you're on the airplane or something, you can continue development and continue testing as if you had the hardware by using the host emulator. But you can also use this actual kit for the hardware and deploy your application directly to the hardware. So I'll set up this little project for all three. And yes, we can also add this to version control so that you can check it in and out of Git or SVN or whatever you're using, but we'll skip that for now. So here we now have a new project, and as you can see, it's set up a profile for us that defines how we're building the project. We have the deployment rules, we have the source code, and we have all of the resources that the application is using. And here in the main form.qml, it's going to open up. Now the screen resolution is a little bit low, unfortunately. So here it opens up the visual editor, so you can easily drag and drop elements to the screen, etc. So for instance, here we can add, maybe another button. We can add that to the row layout, and then it automatically becomes a part of this layout. And then what we can do, we can go back to the QML. Now, okay, it's a little askew here, but now you see that it actually added another button in this UI. If we go into design mode and want to change some elements of this button, okay, the resolution is actually so small. Okay. I can't access all of the menus on the right side because the screen is a little bit too small. But if I, for example, remove this again and we go back, you see that this button is now no longer a part of the source code file. So it provides a very convenient interface for developing these UIs. Here in Qt Creator, we have a list of how you want to compile and deploy this project. So if we start with desktop, we can have a debug. We can choose debug or release. I choose debug mode. And you really just have to press play, and it will run the application. So now this application is running here on the desktop, but this is about embedded development. So how difficult is it then to take a Qt project and make an embedded project out of it? And we can very easily just select this device, debug mode, and then we can compile and deploy this to the device. But now you see there's a red dot there. That basically means it's not connected yet. But then I connect this device over USB and the light turns green. Now I have connected the device over USB and it's communicating directly with Qt Creator. And I can basically just press play, and you see here now it's compiling the application, and it will be pushing it over USB and deploying it directly to the device. And yes, there you can actually see now the same application is running on our embedded device. It's really that simple to get started. It's also possible to do on-device debugging. Now we have set this to debug mode, so I can actually press the play debug version, and now we can set breakpoints in the source code in Qt Creator, and we can do actual on-device debugging. That's very simple to do. You can step into the application, use these visual tools in here. Now it's a little bit difficult to work with because of the low screen resolution. So, and you see it's still loading the application. It's a bit slower than running it in regular mode, but that is to be expected. There are many other things you can do directly on the device in addition to debugging. We also have this Analyze tab here that allows you to do on-device profiling of the application. And one of the things that's very important when you are running an embedded project like this is to have good performance. So being able to have a profiler and actually profile the performance of your application on the device is very powerful. Yeah, I think I'll actually just show some slides of that because the resolution is so low. But before I do that, I just want to mention another thing. It's very easy. Now we have a number of pre-compiled Qt versions, but it's very easy to build your own Qt version for these embedded targets as well. You have to create your sysroot, and you have to know what you're building for. But it's very simple with Qt to, what I did now, I just basically compiled my application and deployed it to the device. I didn't have to set any variables, or I didn't have to do anything specific. All of that is done when you are building Qt itself. So it's easy for you to build a version of Qt yourself for your particular hardware. And these are the most important things you need to think of when you do that. So prefix, that's where you are going to, the folder where you're going to install Qt on the device. And ext prefix, that's on the host machine where you install all of the development libraries when you're doing make install. Host prefix is where you are installing all of the binary tools on your development machine. So that's qmake, mock, UIC, etc. So those are the Qt tools used to build your application. And then the sysroot, of course, which are the development headers and libraries on your host machine. And in Qt 5 we have included this device concept. So that's the make spec, the device you're targeting. So we have a lot of pre-created device specifications, for example, for the Raspberry Pi, for these devices. And you can very easily use those implementations. They are all open, and change them to match your own device that you're using. How are you here? This is information like how are you deploying to the device? Is that over network or over USB? Which ports do you open, etc. And you have the device option, which is the location of your cross-compilation tool chain. So where do you have GCC or Clang for your actual target hardware? And then I just wanted quickly to look at the Qt Quick Profiler that allows you to really look at the performance of your Qt Quick UI. So JIT compiled QML is very difficult to interpret for tools like, for example, Valgrind. So you have all of these classical performance monitoring ways, but that's very difficult. But the profiler really gives you a good way of seeing how your Qt Quick application is working. It will make it simple to see here how the calls in the Qt Quick application is happening, so that you can figure out. Usually you want to use this if you have a problem, right? If your UI is not performant enough, if it's not 60 frames per second, or if it's booting too slowly. And most of those issues is very simple to find and change with the help of the QML profiler. So here you see the whole UI, and we only saw half of this when I tried to show my screen. But you really can run the application, and you can press start whenever you want to start recording, and then stop, so that you don't have to profile your whole application. If you're interested in a specific part of the application, you open the application, you go to that place, you start profiling, you do what you need to do, and then you stop. So you don't have to end up with massive amounts of data. And there is a timeline view of that, so you can have full overview of all of the different aspects of your UI application. The PixMap cache, the scene graph and the animations, the memory usage, the bindings and signal handling, etc. All of this is shown in different parts of the view. So there's a lot of information here and a lot of things you can see. In Qt Creator, we also have, of course, Valgrind and standard C++ tooling and implementations that you can work with for profiling and validating the actual C++ code. I don't think I have the time to start going too much into detail about the different aspects and the different things. But too much JavaScript in each frame is a classical example of when an application starts to look slow. We want to have a new frame being rendered every 16 milliseconds or more. That is 60 frames per second. And that's the industry standard of a smooth UI. And if you see anything lower than that, if you see anything taking longer than 16 milliseconds, you really can use this to figure out why that is happening, and see how you can change it so that you don't have to execute this huge block before you render again. Another really nice thing we have in Qt Creator is this visualizer that will visualize your UI in 3D and show you what's rendered on screen and what's rendered off screen. Very often you're rendering a lot of elements that are completely invisible, and they're taking up GPU and CPU time. So if you can identify that, here you can see there are many elements. So the 3D box you see is a representation of your screen. And then all of the elements below or outside of the screen is not going to be visible. So why would you spend resources on rendering them? So this makes that very easy to catch. Now there's a number of other elements that you can look at as well. But I think I'll just... I think there's three tools in general that I would like to highlight that makes a lot of sense and that really powers embedded development in Qt. And in addition to the Qt Quick Profiler, we have two other features, which is the Qt Quick Compiler and the Qt Quick 2D Renderer. And the Qt Quick 2D renderer is a way for us to actually render your UI without OpenGL. That's something we haven't touched too much upon yet, but Qt 5 is really based on OpenGL. So a lot of people have come to us and asked, hey, I want to have an embedded device with no OpenGL. We don't need fancy 3D graphics. We don't need these super fast animations, etc. So is there some way we can create Qt UIs without OpenGL? And the answer is yes, you can use the Qt Quick 2D renderer. That's a feature that we have in the Qt for Device Creation package that allows you to do that very efficiently. Of course, there are a lot of, it's very easy to implement complex OpenGL UIs in Qt, and if you have done that, the 2D renderer will not render OpenGL calls, it will not render textures, etc. So it's for more simple user interfaces. Another really nice feature is the Qt Quick compiler. And the Qt Quick compiler is another part of the Qt for application or Qt for device creation package that allows you to significantly improve your embedded application. The compiler will, or standard Qt Quick is going to be just-in-time compiled on your device at boot of application startup. It also means that all of the QML files are readable resources that are easily available. The Qt Quick compiler will compile all of your Qt Quick code to C++. So it takes away all of the files so they are not readable on your system. That makes your application safer because it's not open anymore. It will improve the startup time. It will actually also lower the application binary size quite dramatically. And as I said, in some cases, depending on the use case, the actual application execution will also be quite a lot faster. So if you're interested more in these features, we have lots of information about that. Tuka and myself are going to be available throughout the rest of the day, and you can always also contact Bernie here in Korea so that we can set up in-depth trainings, for example. Another of our colleagues, Tino, is actually having a hands-on training session with some developers today, spending 3 full days teaching them all the details about these features. Yeah, so with that, I think my time is up. It's been very nice talking to you. Thank you very much.